tutorial, we want to be doing something on grillage analysis. And today we want to determine the sectional properties of grillage section, an I section, and we're going to obtain the sectional properties of this I section using our computer staadpro. So we're going to be using staadpro to determine the sectional properties, and by the time we are able to obtain this section in staadpro, we can use it to calculate our grillage. All right. Now, apart from using it in staadpro, obtain the properties in staadpro, we can as well decide to make use of the properties obtained from staadpro to calculate to do our manual design of this beam. All right. Now, from our previous video, we treated the HA and HB load, and we're able to draw the bridge configuration. We discovered that beam we have about 5 beams, and they are spaced at 2.45 from mid flange. That is the flange of the composite, the in situ slab, which is 2.45, becomes the width of the in situ slab, while the slab has a thickness of 200. All right, so we are going to have the composite section, but first of all, we're going to have the coordinates of the point. Now, how do you pick the coordinates of a point when you intend to apply it to staadpro? First thing you are going to do if you intend to apply this section in staadpro is to get the coordinates. So the essence of what we are going to do today is, number one, to get the coordinate of the section, and number two, to apply this coordinate in staadpro to be able to generate the section. And once the section is generated, the section can be applied to create our grillage. All right. So when we come to lecture on grillage, we'll be making use of these already defined sections. Now, your staadpro does not have set shapes of this format, so we have to create them in staadpro. All right, so let's go over. We have this beam. We'll start with the beam. This is a precast I section. We intend to make use of this section for the design of prestress concrete. So all the parameters, the figures are there. So what we are going to do, first of all, is to number this section according to the coordinates, starting from the axis of symmetry. We divide this beam into 2 parts symmetrically. All right, so we're going to number them. This is the point, our origin. We'll call it point 1. At this point, we'll call here point 2. Here we'll call here point 3. This point here we'll call it point 4. This point we'll call it 5, 6, 7, 8, 9, 10, 11, 12, 13, and yes, 14. Okay, so we have a total of 14 points which we intend to obtain their coordinates. Now here's our 0 mark, and this x is y. So we'll start with the first point, point 1. We'll move in the anti-clockwise direction. All right, so let's start with point 1. Now for point 1, we are going to have this as point 1. The coordinate here from this point to here is in x, it becomes 3, 5, 5. All right, that is the value. Sorry, the x value will be 0. I think that is the initial state. So at this point, at point 1, we are going to have 0, 0. Now the next point is point 2. At point 2, we are going to have x as 0.355, and y is 0 at this point. Now at point 3, there's point 3. At point 3, we are going to add x to be 0.355, have our y to be 0.231. Okay. Now the next point is point 4. At point 4, we are going to have this point. We're going to have this plus this. So the value here, remember this is 250. The web of this beam is 250. So if we divide it from the middle, it's going to be we're going to have in 0.125. So we have 0.125. So that is 0.4. So the y value becomes this plus this is 463. Okay. So sorry, it's 363. Okay. So we have 0.363. Now the next point is 0.5. In 0.5, what do we have? We have here, so 3.63. So if we add it here, it becomes a 9. So we'll have the x coordinate still remains 0.125. So we'll see how we are 0.125. While at this point, we're going to have here to be 0.9. What are we going to have? 93. Okay. 0.993. Now at point 6, which is this point, we're going to have it as the coordinate. Remember, this is 460. So if we take it down this way, we're going to have 0.230. Okay. So if we have that, y becomes becomes 0.993 plus 993 plus 23. That will give us 6 or 11. That will give us 10. So it gives us 10.106. So 1.016. All right. So that is our point 6. Now 0.7 is in x remains the same, 0.230. Now 0.7 becomes 1.016 plus 0.204. So that will give us 0, 2, 2. So we have 1.220. All right. So we have here to be 1.220. So 0.8. 0.8, we equally have our 0.8, which is this point. So if we have 0.8 at this point, we're going to have it to be a negative value, and that will be negative 0.23. Now, at 0.8 is the same as 0.7. So in terms of y, so we'll have here to be this 0.9. 0.9 in terms of y is same as 0.6. 0.6 is 1.016. 1.9 remains negative 0.23. Now 0.10. At 0.10 remains negative 0.125. At 0.10 is same as 0.5. This 0.5, so we'll have here to be 0.993. At 0.11, this 0.11. 0.11 in terms of y is same as 0.4. This 0.4, so we'll have 0.363. While 0.11 becomes negative 0.125. Now we have 0.12. Now 0.12 is going to be negative 0.355, and the y of it will have it to be 0.231. All right. So this is what we have. Now we have 0.13. Let's go down. 0.13. So if we have 0.13, this is 13. At 0.13, this is our 0.13. So if we add 0.13 here, we are going to have 0.13 to be minus 0.355. All right. Then we have here to be 0. Okay, now let's look at point 14, which is the last point. Here will be 0, here will be 0 at point 14. So this gives us the total coordinates of this precast, the total coordinate of this precast I section. All right, so having gotten this precast section, the next thing we are going to do, having gotten this precast section, the next thing we are going to do is to obtain the composite section. We're going to determine the sectional property of the composite section. Now let's go over and do the composite section. Now we come down here and we create the composite section. All right, let's draw the composite section. So we have it as this. All right, we have it as this. Now remember, we've taken here to be 7. What we just need to do, we're just going to change the position, our numbering. Let's number this way: 1, 2, 3, 4, 5, 6, 7. So let's call here 8. So our 8 becomes our 9 here. So let's call here 8. So let's call here 8. Let's call here 9. Let's call here 10. Let's call here 11. So let's call here or better still, we can renumber them or relabel them. Okay, we can leave 8 to be 8. Let's see if we can do it that way. We have 7 and 8 here. Okay, all right, let's just renumber them. Okay, let's renumber them. So we'll strike out 8 here. Yes, 7. So yes, 7 here becomes our 8. So yes, 7 here becomes our 8. Here becomes our 9, our 10, 11, and let's call it 12, 13, 14, 15, 16, 17, and yes, 18. All right, so I've done the renumbering of the section so that we can calculate it. Remember that here is 200. The thickness of this slab is 200. All right, so I have it as 200. Okay, now having gotten this, we have to calculate the section. Now if you observe, everything will remain the same from point 1, 2, 3, 4, 5, and 6. The coordinate will still remain the same up to point 7. All right, so we can just strike out from 7 downwards. Okay, so we can say from here for point 8. This is our new point 8. So let's just remove this part of it instead of rewriting it afresh. We just remove it. Let's just take it away. All right, so let's start with point 8. So every other figure remains the same apart from point 8. So we can take point 8. So point 7 gives us this point 7. So at point 8, our y value becomes at point 8, our y value becomes yes, 1.22. So 1.22 plus 200 will give us 1.42. Okay, now what will now be our x value from this point down to this? But remember that this flange is 2.45. All right, it's 2.45. So if the flange is 2.45, it means from the center becomes 1.225. Okay, now point 9. becomes 1.225, but at this point, sorry, at point 8, we still maintain the same y coordinate as point 7. Sorry, so we can still have this to be 220. Is at point 9, we're going to have this point 9, we're going to have 200, so we'll now have 1.420. Okay, now at point 10, we're going to have our s value to become negative, but our y coordinate will still remain the same as 1.420. All right, now at point 11, our point 11, we still maintain the same y coordinate, but we are going to have the same s coordinate, sorry. We are going to have the y coordinate of point 11 at this point 11 changing. So if it changes, we are going to have it as the same as that of 7 and 8. So that gives us 1.220. Now at point 12, our y coordinate still remains the same, 1.220, but our s coordinate will become from here down to here, which is negative 0.230. Okay, 0.230. Now point 13 remains the same in terms of s as point 12, 230, and the y coordinates at 12 becomes at 13 becomes the same as that of point 6, which is 1.016. Now at point 14, the y coordinate is the same as that of point 5. We'll have point 5 to be 0.993, and point 14, we have the s coordinate as 0.125. All right, so we have gotten this. The next we are going to look at, maybe we need to write some on the other part of the board, but let's see if we can finish it. We still have some sections, so let's go with point 15. Let's call it 15. All right, point 15. This point 15. Now for point 15, we're going to have the s coordinates to be 0, minus 0, minus 0.125. All right, minus 0.125, and the y of it is going to be that of 4, which is we have 0.363. Okay, now let's look at point 16. This is point 16. At point 16, we are going to have the s value to be negative 0.355, and y of it becomes 0.231. Now we'll go to the next one, is 17. The x value becomes it still remains where it is, 0.355. All right, then the y of it, of course, at point 17, the y becomes 0. Now the last is point 18. At point 18, we'll have 0, 0. So we'll close it at this point. So once we have all these sections, we go straight to our start profile, impute it, and obtain our section. All right, so this, what we've just gotten now, is for the Grillage analysis. Now if we want to work on prestress concrete design, our modular ratio will be used to multiply 2.45 before we apply, if we intend to use that to obtain the section, or we intend to use the parallel axis theorem to obtain the section of the prestress beam. So whichever we intend to use. Remember that this is a composite section of prestress if you intend to design it as prestress concrete. So what we've done today, So we are going to apply this, and we're going to see how we can generate these sections. Now, alternatively, if we decide to design this section with manually, probably using the orthotropic plate method, of course, we can decide to go for additional sections. For example, we need to get the edge beam. Of course, for you to calculate or for you to design using the orthotropic plate method, you must convert this beam, this deck section into an orthotropic plate. When you do that, you can only do that successfully by applying the formula that connects the penultimate beam and the edge beam. Once you apply that formula, you convert the entire bridge superstructure into an orthotropic plate, and you can design it using the methods available like the Morris and Little method of calculating the bending moment of a plate. All right. So, but we are not going to do the orthotropic plate method now. Subsequently, we'll have time to work on this. But let's get this section in staadpro for grillage analysis. All right. So, apart from this section, we also have the crossbeam. If we have the crossbeam, the same method that we use in calculating this section and inputting it in our staadpro file can be used also to determine the properties of the crossbeam, all right, or the diaphragm. Once we do that, we can apply it to our grillage, the diaphragm, and this longitudinal section. So once we have the transverse and the longitudinal section, we can apply our grillage, apply necessary loadings, and obtain the bending moment and shear force the diagram and expression. So thank you very much. Let's go back to our computer lab and let's see what we have. Thank you. Let's go around with our staadpro. Let's go around with our staadpro model. We have our staadpro. Let's pick a file. Call it grillage beam. All right. So call it grillage beam. Or better still, we can come to tools, and from tools we can create. We can click on browse stroke modify data section, or we just go to create user table. All right. So when you click user table, you click your external table, then you input your file name. We can call this file longitudinal girders. All right, longitudinal grillage girders. So under select section type, we look for general section, and all we need to do is to click on our general section. So you can see create user provided table has been generated. At this point, we are going to add up properties. Okay, so let's add a property. The table we have is just table 1, so we'll add property to it. We have to define the polygon. Now we have to impute the data. Okay, now let's go on with the data we intend to impute. Okay, the first one is 0. We have 0 here. We have 0 here. You're gonna click enter. The next we have is 0.355, and we have the next we have is 0 on the y-axis. We enter 0.3. We have 0.355. The next point we are going to have is 0.231. all right, so we enter 0.4 is 0.125. 0.125. We'll have the y coordinate of that point to be 0.125.
0.363. All right, I will go 0.45, 0.5. At 0.5 we have 0.125 for y, for x, and we have 0.993. okay, 0.8, we have negative 0.230, and we have positive 1.22. all right, 1.220. So we go to 0.9. 0.9 we'll have 0.9 will have negative 0.230 for 0.9. okay, that of 0.9y we have 1.016. all right, then we have 0.10, our 0.10, which is minus 0.125. At 0.10 we have the y of 8 to be 0.993. all right, so there's 11. 0.11 we have that's minus 0.10, sorry. 0.11 we have minus 0.125, and we have the y of it to be 0.363. okay, then the last we have 0.12, which is minus 0.355, and we have 0.231. all right, now we have a 0.13. 0.13 we have minus 0.355, and we have 0. okay, now we have the last, which is 0.14. we have 0, and we have 0. okay, so this is what we have. We can name this section. This is what we have. We can name this section. Let's call it section 2, section 1. Section 1. all right, so now it's time for us to compute the sectional properties. The area of the section in meters square, the depth of the section is there, and all that parameter, moment of inertia of the section, sectional modulus on this direction, sectional modulus in the x and in the y direction. okay, so all of these values we are going to obtain as we click the icon compute section. So let's compute section. all right, so now we have computed the section. Let's see the parameters available. With the one we have 4868. In our manual calculation we have 4869 approximately. We have the overall depth of the section to be 1.22, and we have same also 1.22, which is okay. We have the moment of inertia to be 0.0760. we have it in our manual as such. The moment of inertia in the other direction, in the y direction. So let's go over and save this section. Just an approximation. So there are some little approximation that have been done by the software. all right, so let's save this section. So most importantly, two major properties we can see: the moment of inertia, which we have gotten here, is here, and the sectional modulus, which is equally here. We have it here. Okay, so once you have the sectional modulus and you can easily obtain any parameter you wish. All right, so and sorry, this section is a concrete section, so let's add it as a concrete section. So we're going to have it this way. So this is the section we're interested in. We've gotten it. It's an I section. Okay, so the next thing we can go back to our user defined table. Let's make a second section. All right, now making a second section, we are following the same pattern. We're adding. Now we're going to define the polygon. This section we're going to call it section 2. Now this is our composite section. So in working with our composite section, we're going to have it as this. The coordinates goes thus. All right, the point, second one is 0.355. We have 0. Okay, zero. Now the next point we are going to have is 0.9. At 0.9 we are going to have 1.220. Okay, and at 0.12 we're going to have minus 0.23, and our y part of it, we're going to have it as 10.13 remains minus 0.230. I will have at 0.13 we'll have it as what? We'll have it as minus 0.125, and we'll have it as 0.363. Okay, so we have 0.16. 0.16 will have minus 0.355, and here we have it as 0.36. 1.16, so 0.16 is 0.231. Okay, so going 0.17. 0.17 will have minus 0.355, and we'll have the last will be 0. Okay, so 0. All right, so the next we have is 0, 0, 0, 0. So we have 0 here, we have 0 here. So this is the section we have for this. So we can call this section 2. Section 2. So now this section 2, we are going to obtain the properties of section 2. So let's quickly apply the properties and see what we have. All right, so if we look at it carefully, you will discover that the overall depth of the section remains the same. Other parameters are on the screen. So the total moment of inertia of that section, we have it there. The moment of inertia, the area of the section, 97 6875. That is the area of this section. And every other parameters are also there. So this is what we have as the area of that of this section. Okay, so with this I believe we'll be able to impute sections. Can we just save this section? Let's save this section. So let's click OK. So we've done that. So this, we have two sections now. We have section 1, we have section 2. Now these sections are under table 1. Okay, so they are under table 1. So all we need to do to say add, all we need to do is to close it up. So they're already under table 1. So if we go to user, so we can see that just model it. We're going to assign properties to it. Section 1 that we got, let's see it in 3D. Okay, so this is what we have in 3D. Now we will also do the same for section 2 so that you can have a view of it. Okay, we'll do that now so you can see it. All right, so let's assign section 2 to it. We've assigned it. Let's look at it in 3D. So this is what we have in 3D. You can see the section, composite section in 3D. All right, so this is what we have. For notification of our new video, please do well to subscribe. Stay cool.